Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 30 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2359. Find closest node to given two nodes. Okay, let's read the problem statement first. You are given a directed graph, okay, directed graph of n nodes numbered from 0 to n minus 1, where each node has at most one outgoing edge. Okay, the graph is represented with a given zero indexed array edges of size n, indicating that there is a directed edge from node I to node edges of I. And if there is no outgoing edge from I, then edges of I value is equal to -1. All right. So see here, example number 1, right? So here, see, this is 0 node, this is 1 node, this is 2 node, okay, and this is 3 node, okay. So here from 0 edges to 2, okay, so 0 to 2 there is one edge, right? From 1 to 2 there is one edge, okay, and this is directed graph 1 to 2, right? So you see this arrow here, right? 1 to 2, then 2 to 3 there is one edge, okay, so here see 2 to 3 there is one edge, okay, then here 3 and 4 3 here it is -1, okay, that simply means that there is no outgoing edge, right? So the graph is represented with the given zero indexed array edges of size n, indicating that there is a directed edge from node I, okay, at that index to node edges of I, right? And if there is no outgoing edge from I, then edges of I value is equal to -1. Okay, so I hope that you guys are clear with this line, right? This edges, okay, and we have directed graph, okay, of n nodes, right? You are also given two integers, node 1 and node 2, okay, so node 1 and node 2 given to us, all right. We have to return the index of the node that can be reached from both node 1 and node 2, such that the maximum between the distance from node 1 to that node and from node 2 to that node, okay, maximum, it is saying maximum, such that the maximum between the distance from node 1 to that node, okay, distance from node 1 to that node, okay, and from node 2 to that node, okay, that node is minimized, okay, this should be minimized, all right, okay. If there are multiple answers, we have to return the node with the smallest index, and if no possible answer exists, we have to return -1, okay. Note that edges may contain cycles, all right. So now let's understand this line with an example, okay, and these are the constant size, all right, okay, all right. So now see this input, okay, so this is edges given to us node 1 and node 2, okay, so we have to start from node 1 also here, and here from node 2 also, right? We have to start, right? So this is going to have a source, right? This is going to have a source, okay, and we have to check all other nodes. So how many total nodes we have? 0 to n minus 1. Here length of this one is 4, okay, so 0 to n minus 1, 0 to 3 we have nodes, right? So 0 1 2 and 3, okay. So here let's do one thing, okay, let's create two arrays. Let's name them as distance 1 and distance 2, okay. Distance 1 we will take for node 1 and distance 2 we will take for node 2, okay. So this is going to be our first step. So create two arrays, all right, okay, and let's name this as distance 1 and let's name it as distance 2, okay. So here same, right? Here nodes 0 1 2 and here 3, all right, and same for this 0 1 2, okay, and here 3, right? Okay, so now let's do one thing here. Fill all these values with infinity, right? Initially let's fill all these values with infinity, okay, fill this with infinity, fill everything with infinity, all right, okay. Now we have to calculate the minimum distances, right? So it's your choice, you can implement BFS or DFS, okay. So let's understand this with the BFS first, okay. So going to be same approach, okay, for BFS and DFS, right? All right, okay. So now here you are going to call the BFS. Let's call BFS on first, on this one, okay, when we are going to start from node 1, okay, node 1 is equal to 0, right? So let's call BFS on this one, all right, okay. So now here see what we are going to do now, right? So here in the queue, what you need to do in the queue, just pass the start node, all right. So I'm starting with BFS, right? So in BFS we need to create one queue, right? And in this queue just pass this starting node, that is nothing but your 0 right now, okay. So this is starting from, this is for node 1, right? Node 1, and node 1 is starting from 0, okay. So now here this is our node 0, okay, and now we are going to start from here. So create one biscuit array, okay. We have to keep track whether we have already biscuit this or not, right? So we are starting from here, okay, and here initially create one boolean array also, right? So let me draw that as well, boolean array, all right. So let's say this is your boolean array visit, okay, visit All right, so here this is 0 1 2, okay, and here 3, and here let's fill false false. Okay, everything is false. Okay, we haven't wasted anything, right? All right, so now here we are starting from 0, right? This 0, so 0 to 0 distance is going to be 0 only, right? We are sitting here only. So, okay, this is our start. So from 0 to 0 distance is going to be 0 only, so I can change this infinity to 0, right? Okay, so I can change this to 0. All right, so now this is done. Okay, now what you need to do from the queue. Okay, so here let's say this is your queue. In the queue, what did you add? Previously you had 0, right? So just pull this 0 out of this queue. Okay, pull this queue, pull this 0 out of this queue, and here we haven't visited this 0 yet. Okay, so mark this as visited. All right, so mark this as visited, true. All right, and now for this 0 there is going to be only one neighbor, right? So for this 0, if you see 0 to 2, okay, only one neighbor, 2 is there, right? And here you see 0 to only one neighbor, right? So here this value is not equal to -1. That simply means that there is one outgoing edge, right? And we haven't visited this 2 yet. Okay, we haven't visited this 2 yet. Okay, for value is false. So now what you have to do here, that simply means from 0 to we are moving. So here in the distance, okay, initially the distance value from when we are going to start, it is 0, right? Now from this 0 we are jumping to this 2, right? So distance is going to be 1, right? We have to add 1 to the distance. Okay, 1 plus this node distance is 0 only. So here it is going to become 0 plus 1 1. Okay, so I'm going to change it to 1. All right, so 0 plus 1 1, right? So here that is true now. 0 to distance is 1. Okay, now once this is done, okay, now in the queue what you need to do, you have to offer this neighbor. Okay, so neighbor is this 2. Okay, just add this, right? This is done. So now in the queue you have added this. Okay, now same thing, right? So right now again your queue is not empty. So what you need to do, you have to pull this element 2 outside. Okay, and now we haven't visited this yet, right? So I'm going to mark this as visited. So here I'm marking it true, right? So now here see, for this 2 we are moving to 3. Okay, from this 2 we are moving to 3, right? The value is not -1 here, it is 3. So that simply means 2 to 3 we are moving, right? So here 3 we haven't visited yet, right? 3 we haven't visited yet. Okay, right? So now what we need to do, so we have to visit that. Okay, minimum distance first, we have to minimum, right? Minimum time, minimum time we have to reach, right? Here, so from this 2 we are moving to this 3. Okay, so here 2 1, when we are reaching distance of was 1, right? So now it is going to be 1 plus 1 here. Okay, 1 previous 1 and plus 1, so it is going to become 2, right? Okay, so here this value is infinity, right? So here I'm going to update it to 2, right? Okay, and that is 2 now. 0 2 2 1 2 to 3 1. Okay, so total 2, right? So here I'm operating 2, right? All right, so this is done. Okay, and now in the queue just add this. Okay, 3. All right, so now again same process. You haven't visited this 3 yet, pull this 3 outside. Okay, and now you haven't visited this 3 yet, so again here what you need to do, you have to mark this as true, right? Okay, and now see here from this 3 uh from this 3, after that you are moving here, it is -1. Okay, so that simply means we can't move anywhere else. Okay, there is no outgoing edge. Okay, so in that case what you need to do, you have to do nothing, right? And now again you have to check the queue. Okay, so it is empty now, we have to stop. That's it. So that's it. Okay, so starting from 0, if you see here we are starting from 0. Okay, so 0 to 2 we are reaching in 1. Okay, 0 to we are reaching in 1, and here 0 to 3 we are reaching in 2, and we are never reaching to just 1. 0 to 1 we are never reaching, right? There is no outgoing edge, so here it is still infinity. Okay, so this is what we need to do, right? This is going to be our first step, right? So now same way you have to do, calculate this distance 2, right? You have to update this, but this time you are starting from this node 1. Okay, node 2 is values 1, so from 1 we are starting. Okay, so again same thing, right? Again you have to same thing. Okay, so this is infinity only, right? Okay, right now you are at 1, so you have to update this to 0. Okay, you are starting from 1, you have to update this to 0. Okay, right? And now in the queue you have to add this one. Okay, you have to add this one. Same way you have to update this. Okay, visited array also you have to keep track. Okay, so let me draw that. Okay, otherwise you guys will get confused. So let's say this is your uh, boolean visited array for this second. Okay, so here initially you have to set all the values to false, right? All right, and in the queue you are going to add 1 first. Okay, because you are starting from 1, right? So here you have to add 1, right? So now we haven't visited this 1 yet. Okay, so first poll, and here 1, mark it as true, mark it as true. Okay, now here from 1 where we are moving, we are moving to 2. Okay, at distance 1. Okay, so here this 0 and we are moving to 2. Okay, at 0 plus 1 1 only, so here we have to update this one. All right, and in the queue you have to add a 2. Okay, in the queue you have to add 2. Okay, now from here 2 is there, right? So now from 2 you are moving to 3. Okay, 2 to 3. Okay, it is not -1, so you can move, right? So 2 to 3 you are going to move in again plus 1, right? You have to do, and you have to mark this 2 as true also here. Okay, and 2 to 3 you are going to update it to 1 plus 1, that is 2. Okay, this is done. And then after that 3 you are not going to move anywhere, right? Value is -1. Okay, so here same way you have to add 3 also now. Then you are going to check 3. Okay, 3 you are going to mark it 2, but from 3 you can't move anywhere, right? So that's it. Okay, so this is going to be your distance 2, right? So this is also 2 now. 1 to 2 1, 1 to 3 2. Okay, and 1 to 0 you can't never reach. Okay, you can't reach. Okay, so that's it. So this is how you have to fill this. All right, so now once this is done, okay, using BFS, once you did all this, then after that what you need to do, so here see now what you need to do. Okay, so now create one variable. Okay, let's say create one variable, minimum distance node. Okay, min distance node, and set it value to -1. Okay, and here initially just take create one more variable, minimum distance till now. Okay, minimum distance till now, and set is to integer dot max underscore value, let's say infinity, right? So now you have to check all the nodes one by one. Okay, 0 1 2 3, all the nodes, right? So here if you see, initially you are checking this 0 node. Okay, right? In the problem statement it is given that if there are multiple answers, then we have to return the node with the smallest index. Okay, so let's start with 0, right? Okay, so now here for this 0, if you see, right, initially right now our minimum distance till now is nothing but infinity only, right? So is this infinity, okay, minimum distance till now, okay, if this value is greater than math dot max, okay, math dot max value of distance 1 current node and distance 2 current node. Okay, so here we have 0, and here we have 0, and here we have infinity. Okay, is this value infinity is greater than this? No, no. Okay, from here also we are taking max, right? This is not. All right, same way here also, infinity and 0, it is again going to be infinity this side, and infinity here also, infinity is greater than infinity. No, right? Now for node 2 we have to check. Okay, so here 1 plus 1. Okay, 1 and 1. Okay, so 1 and 1, what is max? Max is just 1. Okay, and now tell me, infinity is greater than 1? Yes, this time it is true. Okay, if it is true, then you have to update your minimum distance node. Okay, minimum distance node. Okay, this value, okay, it was -1. Now set it to current node. Current node is nothing but 2. Okay, this 2. So here set it to 2, and minimum distance till now, minimum distance till now, okay, you have to update it to math.max of this value 1 and 1. So what is value here? 1 and 1. What is max? 1 only. So here you have to update 1. Okay, now next time here you are going to check update 1 here, and 1, tell me 1 is greater than here 2 and 2, what is max? 2. Okay, so 1 is greater than 2. Okay, false, right? So that's it. Okay, so in the end you have to just return this minimum distance node. Okay, so 2 is the output. Okay, so you have to just return the node, right? So distance, now understand this, the distance from node 0 to node 2 is 1, and the distance from node 1 to node 2 is also 1. The maximum of these two distances is 1. It can be proven that we can't get a node with a smaller maximum distance than 1, right? So we return node 2. Okay, so we are returning node 2. All right, okay, not this 2, we are returning node 2, right? We have minimum value. Okay, so here we are reaching first, right? Okay, minimum distance there. Okay, minimum distance 1 1. Okay, it is there. So we have to return the minimum distance when we reach, right? So this is what you need to do, right? So now let's write the code, and then you guys will get much better understanding, okay, of this one, right? It's very simple, nothing complex, right? So here what you need to do, this is your code here. So here you can do one thing. First, just calculate the length of edges, right? So here let me write it like this, and is equal to edges dot length, right? And then create two arrays. Okay, distance 1 and distance 2. Okay, distance 1 is equal to new int n. All right, and then create one more array, distance 2, let's say, and here new int n. Okay, now after this what you need to do, you have to fill all the values with infinity. Okay, max value. Okay, so here arrays dot fill, and here distance 1 with integer dot max underscore value. All right, okay, this is done. Now just copy this. Okay, and same you have to do for your array 2. Okay, distance 2. Okay, integer dot max underscore value. And once this is done, then just call the BFS. Okay, so here you have to write BFS. Okay, BFS, you are going to call this method. So in this BFS, just pass the node 1. Okay, your starting point, right? And then just pass the edges that you have, right? And just pass the distance 1. Okay, we are going to update distance 1 using this BFS. Okay, and same way, same thing we have to do for our second start point. Okay, node 2, and here again pass distance 2 pass and edges, right? That's it. All right, so this is done. Okay, now after that here just create min distance node. Okay, min distance min dist node, you can say. Okay, here you can pass -1, and here mean distance till now. Okay, here integer dot max underscore value, right? This is what you need to pass, and now just you have to run one loop. Okay, here for int you have to check all the nodes. Okay, so cur node is equal to 0, cur node is less than n, and here cur node plus plus. All right, and here after that, here just check the condition that I told you, mean distance till now. Okay, mean distance till now, if it is greater than the math dot max of distance 1 cur node. Okay, and here you have to pass distance to cur node. Okay, and here after inside this, what you need to do, you have to update the mean distance node is equal to cur node, and here mean distance till now you have to update it to math dot max of, here just copy this distance 1 cur node and distance 2 cur node. Okay, copy this and pass it here. All right, so from here you have to just return the mean distance node. Okay, so that's it, return mean dist node. Okay, so we did all this, right? These all steps we did, right? Now we have to just fill these values, right? So using BFS. Okay, so now let's write this method BFS. All right, so here what you need to do, just write void method. Okay, public void BFS, and what you are passing, you are passing the start node. Okay, so here int start node, and then you are passing edges. Okay, so here int edges, and then you are passing distance. Okay, int dist. Okay, and now here int n is equal to edges dot length. All right, and here take q, integer q is equal to new linked list. All right, and here in the queue just offer the start node. All right, boolean visit is equal to new boolean and. All right, and here you have to pass arrays dot fill visit, and here you have to pass boolean dot false. Okay, so you have to fill all this here, and then here you have to update distance. Okay, start node, from where we are starting we have to just pass the 0, right? Here start node is equal to 0, and here you have to write while your queue is not empty. Okay, until then you have to execute this. Okay, so simple BFS code, okay, that we usually use, right? Queue is not empty, so here you have to poll this. Okay, so int node is equal to queue dot poll, and then after that, if you haven't visited this, okay, if you have if you have already visited this node, then there is no use to visit again, right? If you have already visit this node, then in that case just continue. All right, and here just update visit node is equal to true, and here int neighbor is equal to edges of node, and here just check if neighbor is not equal to -1, and not visit of neighbor is equal to distance of neighbor is equal to 1 plus distance node, right? And here in the queue, then you have to just add this neighbor. Okay, neighbor, that's it, and that's it. Okay, this is void. All right, so now let's run the code and see if the code is. We'll try to fix that. So see, all the test cases has been accepted. Now let's submit it. All right, so our solution is accepted, right? And the time complexity is just going to be O of n. Okay, simple BFS, right? So now let's move to the DFS approach. Okay, so only few lines we have to change, that's it. Okay, so let's write the code for DFS now. Okay, so here let's don't change anything here. Do one thing. Instead of using it here now, you can try to use it here only. Okay, so let me just copy this here, just go here and paste it. Boolean, do one thing here. Boolean visit 1 is equal to new boolean n, and here same way for visit 2 you have to do. So just copy this, paste it here. Boolean visit 2 is equal to new boolean n, and here same way, this is for visit 1, let's say, and same way you have to do for visit 2 also. Copy this, paste it here. This is for visit 2. Okay, now this is done, and then here instead of BFS, let's use DFS. Here also let's use DFS, and here just pass node 1 edges distance 1, and here just pass visit 1. Okay, we are just going to go use this visit 1 from here only, and here also visit 2, and all this I think it will remain same. There's nothing required. Okay, no change required here. Now here just change this method. Instead of BFS, let's just use DFS, and here we have to just update few things, right? We are passing total 4 things: int node, int edges, int dist, and here we are passing this visit in the parameter. Okay, so boolean visit, right? So now this is done, and here from here what you need to do here, visit of node, okay, set it to true. So let me just delete all this. Okay, visit of node, set it to true, and take the neighbor, okay, edges of node, and here just same condition. If neighbor is not equal to this -1 and we haven't visited this particular neighbor, then distance of neighbor updated to 1 plus distance plus node, and here instead of this just simply call this. That's it. Okay, that's it. Okay, so here DFS, here now this time you have to pass the neighbor, okay, as the current node. All right, so this neighbor, and here edges, and here distance is visit only, not visit 1, visit only. Okay, and that's it. Okay, so this is done. This is for this, this is for this. Okay, this is not required. All right, that's it. I don't think any other change is required. Only 35 lines of code. Let's run it. So yes, there are some issues. Let's fix that. Okay, it should not be distance 1. Okay, only distance. Let's run it again. All right, so there is some issue here. So let's see where we are missing something. Here we are not setting distance 1 of node 1, right? So here you do one thing now. Distance 1, okay, to itself. Okay, we are starting from here now. So node 1 you have to write here. Okay, distance 1 node 1, just change it to 0, and here also just change this to distance 2 to node 1. Okay, we are starting from here, so we have to update it to distance 2. 1 second. Distance to node 2 is equal to 0. That's it. Okay, let's run the code again and let's see. So nice, all the test cases has been accepted, right? Let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in the comment section. Till then, keep coding and keep practicing. We'll see you in the next video. Thank you. Bye bye.